This is Proof of Proficiency, or POP, Part 2, Scripts and Production. Participants will need the following materials before starting this PD: a printout of a math flow map and blank script, or a printout of an ELA flow map and blank script. If you choose ELA, you may also want to print out the example passage in question to use later. The objectives for this plugin are: participants will be able to create their own POP script and create their own POP. Let's focus on one objective at a time. First, participants will be able to create their own POP script. Before we look at some scripts, please note that these are just examples of scripts. As a teacher, you could add or eliminate pieces to work best for you and your students. Let's see an example of an ELA script. When you watch this video, think about what do students need to include in this ELA POP script.
This is the first slide, and it's just pretty much the standard number and that it's a Common Core reading standard. Then the second slide is the full standard in your own words. For example, what I put for mine is the standards to teach us how character setting and plot interact with the story. And then this is just a small part of the standard that we're going to be focusing on in the video, where my example is this lesson will focus on how the plot changes the characters, where I didn't even use the setting. I just focused on one part. And then the second one is vocabulary. You have to introduce it in the first slide, and then the two other ones, you have the vocabulary word and the definition. And then the next one, you introduce the book, which in this case is The Hobbit, and then you explain the event that you're going to be talking about and how we're going to use the standard to show how the plot changes the character, and in this example. And then you use a citation from the book and you explain how this pertains to the standard. And then this one is this is a review slide where it shows that we're going to be reviewing. And then it restates the focus, which in this case is that the characters are changed by the plot, and then the works cited with your name, navigator schools, and the book.
What do you use this for? What's your next step after creating this script?
After creating the script, you have to make a video using Powtoon.
And what is that called?
A pop video.
Thank you.
Please pause this video to reflect on the question, either aloud with a group or silently by yourself. Now that you've had a chance to reflect, you heard the students say that the script includes the standard, a standard description, an objective or focus statement, and some vocabulary. The script also includes a question based on a book they are reading that relates to their standard. Then they answer the question in detail. Now let's see a script for math. When you watch this video, think about: what do students need to include in a math POP script?
Okay, so this is basically the outline for our math proof of proficiency videos. First, we start with our standard over here. We list our standard, and then we write our I can statements. These are usually in an app, or we are told by the teachers on the standard. And then we give an example problem. We don't necessarily have to use this, and then we list some vocabulary. And then our next page is basically where we word it out word for word, because it's our script. It's what we're using when we're making the POP video. For example, we basically fill in the blanks and we use the vocabulary words on the previous page, and then some common misunderstandings that people would usually make. And then a simple example problem. This doesn't have to be very intricate, or we don't have to use a real world problem necessarily. And then basically in here we're going to use the steps to solve this problem. Again, it has to be word for word because this is what we're going to use when we're making the video. And then our next page, it's a little more detailed, and it's a real world example problem. We need to create this ourselves. We're not allowed to use anything from the internet. We are allowed to use examples and get ideas, but this has to be something from our own minds. And basically here, like I said, we write it down word for word and we explain the steps like how we would in the video. And then basically we just restate what we did throughout this whole video, and one of the important things we do is how we'll use this standard in the real world problem, and basically it's basically restating what we did on the previous page. And then here, when we're all done, we check if we did everything here. This is how we basically ensure we got a good grade, something that in case we miss something, we make sure to check it off oh, I missed this, let's go back and fix it. And then here is where we check one more time to make sure that, oh, the introduction, it had the standard description, and for the vocabulary, it has pictures and stuff. Basically, just to make sure that we got a good grade, something that we really tried on. And basically, after we fill this out, we make a pop video, like I said, proof of proficiency, explaining the standard that we've spent the previous week or so learning. And it basically explains what we've been doing, and it basically tells us, it basically shows the teacher that we know what we're doing and that their instructions really helped us.
Please pause this video to reflect on the question, either aloud with a group or silently by yourself. Now that you've reflected, we see that a math script includes a standards research circle map, the objective, vocabulary, common misunderstandings, a simple problem and answer, a real-world problem and answer, and a conclusion. Here's a science script. When you watch this video, think about, what do students need to include in a science pop script?
So this is our science pop script. The first thing you would do is find the unit and then the concept, and then you would have to go to Discovery Textbook and you'd find your, well, it depends on how many questions you have, and you'd start your tree map and then write down on your tree map the focus questions you want to focus on, and then have to go through the passage and find the main stuff you need and write it down on that focus question. This one is where you have to find the vocabulary. So say you have cell, you have to put cell right here, and you have to find the definition on Discovery Tech or anything you can do to find the definition for that word. This one is pretty much like, this one we kind of already know. It's like the math one, the ELA one. If you do pop in ELA, pretty much just have to put your name. If you're working with someone, put like, hi, we are Giselle, Ashton, and Giovanni, like I do. Or you can do, like, if you're just doing a pop by yourself, you can do, hi, I am Giselle from Navigator Schools. You put, in this video, you will learn about whatever concept you are, and try to focus on the details so people, like, if they're watching your video, they know what you are certainly talking about. This one is, like I said before, you would have to find the best question on your tree map. Find the race response and write it down with all race, the restate, the answer, the site, and then explain it. Then you have, it depends on, again, how many questions you have. If you only have 2 questions, you only write it, the one race question, and then the summary on 1 or 2 or 3, depends. Just a quick little summary on the question. Then you do your conclusion, like, now we've learned, and you have to restate your introduction. So, like, you learned concept 12, and then what are the 2 questions you were mainly focusing about?
What do you use this script for, or what would be your next step after you finish your script?
Well, we lay it all out, and then we start on our pop.
Please pause this video to reflect on the question, either aloud with a group or silently by yourself. Now that you've had a moment to reflect, we can see a science script includes an objective and multiple questions based on their readings. They must include a detailed answer for one question and summaries for the other questions. Remember, these scripts are examples and can be modified to fit the student's needs and your curriculum. Here is a teacher exemplar of a math pop script and an ELA pop script. What do you observe? Please pause this video to reflect on the question either aloud with a group or silently by yourself. Hopefully you noticed that a lot of writing is required for scripts. Each section is very detailed and there is a checklist at the end to make sure all components were addressed. Now it's time for a written reflection. Please pause this video to write down your thoughts from the See It videos. Why is the script so important in the making of the pop? If you are with a group of people, please pause the video again and share your written reflection with each other. Now that you've reflected, we see that without the script, the pop will feel unprepared. The script provides word for word what the student will say. Without it, students may fumble over words as they record. Students also need to do a significant amount of writing and editing before they start producing a pop. So we've come to our core idea. An exemplary script is key to making an exemplary pop. The script provides writing and editing practice for the students. So why is this important? Please pause this video to reflect either aloud with a group or silently by yourself. This is important because if there's no script, students will fumble over their words and have no clear path for their objective in the pop. Writing is also a big part of the script, and writing should be incorporated in every subject, including math. The best way to fully understand the components and effort it takes for a student to create a script is for you to create your own script. First, choose a subject, either ELA or math. Then, choose a standard to research and focus on. You can go to the Common Core website to choose your standard. If you choose ELA, you may write your question and response based on any book you've read or use the passage in question provided. Use the flow map to help keep you on track for creating your script. Pause this video to work on your script now. Please pause the video again to share and discuss your scripts with your group. Here's the math exemplar from the See It video. Here, the presenter researched the math standard. In this case, it's a 5th grade standard, NF1. Students can include example problems, vocabulary, or anything that helps them understand the concept. This presenter researched the standard using the app iExcel, Khan Academy, and teacher-made slides and questions. Here's the start of the script. Students introduce themselves and the objective they will be showing. This page also includes vocabulary and any common mistakes made. This part of the script shows a simple example problem. The problem is solved and the student is required to write out their explanation. So for example, this presenter's simple problem was 1/2 plus 3/4. After she solved it, she wrote, "Our first problem is 1/2 plus 3/4. I can see I don't have common denominators. Let's find the least common multiple between my denominators of 2 and 4. I can see the LCM is 4. If I multiply 1/2 by 2 over 2, I get an equivalent fraction of 2/4. My new equation is 2 over 4 plus 3 over 4. Now that I have a common denominator, I can find the sum. 2/4 plus 3/4 equals 5/4. I can check my answer by drawing a model to represent my fractions. I also got 5/4, so I know I solved it correctly. The presenter literally writes out step for step how she solved the problem. Then, students create a real-world problem. Again, they solve the problem and write out their explanation in detail. Please pause this video to read and reflect on the detail this presenter included in their writing. The final piece concludes the script, reiterating the objective and how it relates to the real world. The presenter wrote, "Now you will be able to add fractions with unlike denominators. You will use the standard in the real world like Sally did. She needed to add 2 different amounts of liquid and needed to know the total amount of liquid. When you have 2 amounts of liquid and the fractions have different denominators, now you will know how to add them." Now let's look at an ELA exemplar. This is where the student looks at the standard and chooses an objective to focus on. In this case, it's a 4th grade standard, RL3. Vocabulary is defined so the student can fully understand the objective. The pop will be based on a question relating to a novel or passage. Both are written at the bottom. Please pause this video to review each section. This is a double bubble thinking map showing the similarities between 2 characters from the passage. The presenter read the question and read the text. As they read the text, they took notes on this thinking map. The question was based on the standard they researched. Here's the start of the script. Students introduce themselves and the standard. Academic vocabulary is given, and the grade level text that will be used. All of this was found on the previous standards research summary page. This is where the presenter introduces the question that is based on the standard. The presenter also writes a detailed response, citing evidence from that text. The presenter wrote, "In order to address this standard, let's look at the passage called Running Like a Pro by Aditi Sriram. We're asked about a father and son similarities. Julian and his father have a lot in common. What evidence from the story supports this statement?" The presenter then responds with a detailed, evidence-based answer. Julian and his father are very alike because they both have hazel eyes and big ears. They look so alike that people would say to Julian, "Aren't you a spitting image of your dad?" Paragraph 1. Both Julian and his father also like to run. According to paragraph 2, when Julian's father began training for a marathon, Julian found himself wanting to run as well. This evidence proves that not only do Julian and his father look alike, they also like similar activities. Finally, the presenter shares the connection between the question and the standard and concludes the script. The presenter writes, "This question helps us show mastery of the standard because we are giving specific details on a character based on physical and personality traits. We discuss in depth about Julian's qualities and can make a picture in our minds about what he looks like. Now you will be able to describe a character drawing on specific details from the text." It's time for a written reflection. Please pause this video and take a minute to write down any key takeaways from writing a script. Let's move on to our next objective. Participants will be able to create their own POP exemplar. Let's see a math exemplar of a POP using an app called Explain Everything. When you watch this video, think about how does the speaker sound on the video, prepared or unprepared, and why do you think that? And what makes the video engaging to a viewer?
I am Miss Corral from Navigator Schools. This is Standard 5 NF1, and in this video you will learn how to add fractions with unlike denominators. You will need to know a few academic vocabulary words to help you understand this standard. The first word is sum. The sum is an answer to an addition problem. So I have 2 apples plus 1 apple equals 3. 2 plus 1 equals 3. 3 is the sum. Our next word is fraction. A fraction is parts of a whole. It contains a numerator and a denominator. Here are some fractions written in number form, and here are some fraction models shown. Our next word is numerator. Numerator is how many parts we have. It's the top number of a fraction. Another important word is denominator. The denominator is how many equal parts in a fraction. It's the bottom number of a fraction. Our last vocabulary word is least common multiple. This is the smallest multiple between two numbers. So for example, if I was looking for the LCM of 2 and 6, first I would need to write out the multiples of 2. 2, 4, 6, 8, 10, and of course I can keep going. Now let's do some multiples of 6. 6, 12. Oh, but I can stop because I see that I have a common multiple already. The smallest common multiple is 6. So the LCM of 2 and 6 would be 6. A common mistake is adding the denominators. Don't do it. 1/2 plus 3/4 does not equal 4/6. You must find a common denominator. So our first problem is 1/2 plus 3/4. I can see I don't have a common denominator. Let's find the least common multiple between my denominators of 2 and 4. So my multiples of 2 would be 2, 4, 6, 8, 10. I'm going to stop there. And my multiples of 4 would be 4, but I can stop there because I'm looking for the least common multiple. I can already see that they have 4 in common. 4 would be my LCM. If I multiply 1/2 by 2 over 2, that gets me to my denominator of 4. And when I multiply by a fraction that equals 1 whole, I'm not really changing the fraction. If I multiply my numerator, 1 times 2 equals 2. So 1/2 has now turned into 2/4. If I multiply 3/4 by 1 over 1, because that will get me my denominator of 4, and again, I'm multiplying by a fraction that equals 1 whole, not really changing the fraction. If I multiply my numerator, 3 times 1 is 3. 3/4 actually stayed the same. Now that I have a common denominator of 4, I can find the sum. 2/4 plus 3/4 equals 5/4. I can check my answer by drawing a model to represent my fractions. 1/2 has turned into 2/4. 3/4 stayed the same. I also got 5/4 as my answer, so I know I solved it correctly. Here's a real-world problem for you. On a hot day, Sally poured 9/10 of a bucket of water into a plastic wading pool. A few minutes later, she added another 1/2 of a bucket. How much water did Sally pour into the pool? First, I need to understand the question. I know that 9/10 and 1/2 are important numbers. I also see a key word, added. This tells me that I need to add my two fractions in order to find the total amount of water that Sally poured into the wading pool. I know that when I add fractions, I need a common denominator. I don't have that yet. Let's find the LCM between our two denominators, 10 and 2. I can see that my LCM is 10. That is the denominator I need. If I multiply 9/10 by 1 over 1, 10 times 1 gets me to my common denominator of 10. 9 times 1 equals 9. 9/10 actually stayed the same. And if I multiply 1/2 by 5 over 5, 2 times 5 gets me to my common denominator of 10. 1 times 5 gets me 5. So 1/2 turned into 5/10. Now my new equation is 9/10 plus 5/10. 9/10 plus 5/10 equals 14/10. I can check my answer by drawing a model to represent my fractions. I can see 9/10 has stayed the same. 1/2 has an equivalent fraction of 5/10. 9/10 plus 5/10 would equal 14/10. I can see that my answer is the same. So to answer the question, Sally poured 14/10 buckets into the plastic wading pool because once you find the common denominator, the sum between 9/10 and 5/10 equals 14/10. Now you will be able to add fractions with unlike denominators. You will use the standard in the real world like Sally did. She added 2 different amounts of liquid and needed to know the total amount of that liquid. When you have 2 amounts of liquid and the fractions have different denominators, now you'll know how to add them. Thank you for watching.
Please pause this video and write down what you observed. Here's an ELA exemplar using a website called Powtoons. When you watch this video, think about, how does the speaker sound on the video? Prepared or unprepared? Why do you think that? And what makes this video engaging to a viewer?
created using Powtoon.
Please pause this video and write down what you observed. Here's a science exemplar using the app Explain Everything. When you watch this video, think about how does the speaker sound on the video, prepared or unprepared, and why do you think that? And what makes this video engaging to a viewer?
Hi, we are
Jason, Nicole,
and Orlando from Navigator Schools. In this video, you will learn about kinetic energy. You will learn about the relationship between kinetic energy of an object, its velocity and mass, as well as how it's transformed into potential energy.
a few vocabulary words you need to know are force, the interaction that causes a change between motion of objects. Velocity, the speed or direction of moving objects. Acceleration, a change in velocity.
Kinetic energy, the energy an object has because of its motion. Potential energy, the amount of energy that's stored in an object. So you can see here, the ball will have more kinetic energy, and the balloon has potential energy stored inside of it. What is the relationship between the kinetic energy of an object and its velocity and mass? The relationship between the kinetic energy of an object and its mass and velocity is the energy of motion. According to Discovery Textbook, the kinetic energy of the object is dependent on the mass of the object as well as its velocity. If an object has a mass, m, and a velocity, v, then its kinetic energy, Ke, is as follows. Ke equals mv squared divided by 2. This shows that if an object is moving forward, it is dependent on the mass and its velocity to increase the amount of kinetic energy. For example, if both of these vehicles were traveling at a speed of 50 miles an hour, the truck would have more kinetic energy because of the bigger mass. Also, if the vehicles accelerate, the kinetic energy of both vehicles will increase.
How is kinetic energy transformed into potential energy? Kinetic energy is transformed into potential energy by using force. When an object in motion stops moving, it loses kinetic energy. For example, when you stretch a rubber band, its potential energy is released. Rethinking everything we have learned, we have shown you how kinetic energy works.
You have learned that the relationship between the kinetic energy of an object and its mass and velocity lies within its energy of motion and force, and how kinetic energy is transformed into potential energy.
Please pause this video and write down what you observed. Now it's time for a reflection. Please pause this video to discuss these questions based on the See It videos. How did the videos look? Prepared or unprepared? Why do you think that? And what makes these videos engaging to a viewer? Now that you've had a chance to reflect, hopefully you noticed that the videos looked and sounded very prepared. The only justification for this is that the presenters must have written a very detailed, thorough script. The videos are engaging because pictures and color were used, and the speakers spoke accurately, without stumbling over their words. The production methods, an app called Explain Everything, and a website called Powtoons are just a few examples of how to make an engaging pop. Let's now discuss why the output of production is beneficial to students. Please pause this video and discuss with the group the following question. Why is it beneficial for students to show proficiency of a standard using POPs? Now that you've discussed, we saw how engaged the students were and the collaboration that came along with script writing and pop creation in part 1 of this PD. Students are motivated with this type of learning. Students are using many forms of technology to produce wonderful work, which sharpen tech skills as well. So we've come to our second core idea. POPs increase student engagement and collaboration and provide application of the standards using technology. Now it's time to practice. You will use your script from earlier to make a pop on the Explain Everything app, Powtoons website, Google Slides, Prezi, or any other similar app. If you are unsure of how to use these programs, please refer to the resources at the end of this PD for how-to videos. Make sure your pop includes all parts of your script and your pop is around 5 minutes long or less. Pause this video so you can create your pop. It's time for another written reflection. Please pause this video to write down your thoughts from creating the pop. We've come to our final reflection. Please pause this video to discuss the following questions. How will this affect your classroom? And how will this impact your students? Thank you for watching part 2 of the Proof of Proficiency Professional Development.